Hi, 7th grade. Welcome to lesson 7-4, use probability models. By the end of the lesson, I want you to be able to say, I can use probability models to find probabilities of events. Let's explain it. The chess club has 8 members. A new captain will be chosen randomly, selecting the name of one of the members. Leah and Luke both want to be captain. Leah says the chance that she will be chosen as captain is 1/2, because either she is chosen for captain or she is not. Luke says that the chance he is chosen is 1/8. Construct arguments. Do you agree with Leah's statement? Use a mathematical argument to justify your answer. So I would say, no, she does not have a 50% chance of winning. Or being picked, rather. Chance of being picked. Because it's either her or it's the other 7 people. It's not either her or Luke. Construct, do you agree with Luke's statement? Use a mathematical argument to justify your answer. Yes, because he is one person out of 8 total people. Yes, because 1 out of 8 is the probability he is picked. Which is also the same probability for Leah, and 1/8 does not equal 1/2. Focus on math practices. How does the probability of Leah being chosen compare to the probability of Luke being chosen captain? 1/8 is equal to 1/8. So they have an equal probability. And they're both unlikely to be picked. So it's less than 50%. Example number 1. Develop a probability model. Mr. Campbell has a jar on his desk that contains 10 marbles. At the end of class, each student draws a marble from the jar without looking, notes its color, and then puts it back in the jar. If a student draws a red marble, the student gets a pass on that day's homework. How can the students determine the probability of drawing a red marble? How can you use a model to help you predict what color might be drawn? So you're going to develop probability models this lesson based on a theoretical probability, so based off what should happen. Probability model has 2 things. It has the sample space, and it has the events within the sample space and their probabilities. A sample space is the set of all possible outcomes. When a marble is drawn, there are 10 possible outcomes. So here's all of the possibilities that you could get. You could pick 1 red, you could pick 3 greens, or you could pick 6 purples. So the R represents the red, G represents the green, and P represents the purple. Now with all the possible outcomes, there's only 3 different events. Picking a red, a green, or a purple. Then we'll write the probabilities. So the probability of getting a red is 1 out of 10, because there's only 1 red out of all 10. Probability of getting a green is 3 out of 10. And the purple is 6 out of 10. So the students in Mr. Campbell's class can use a probability model to determine that the probability of drawing a red marble is 1 out of 10, or 10%, which is pretty unlikely. Try it. Mr. Campbell decides that too many students are getting a pass on homework. He adds 10 yellow marbles to the jar. Tell whether each part of the probability does or does not change. The sample space. Sample space is how many? Remember that our sample space was here. Does the sample space change? Yes, the sample space does change, because now it's going to include the 10 yellow marbles. Each event within the sample space does not change. It doesn't change the amount of red we have. It doesn't change the amount of green or purple. But the probability of each event does change, because now instead of being 1 out of 10, instead of being 1 out of 10, it's going to be 1 out of 20 for the red. The green is now, instead of 3 out of 10, it's 3 out of 20. And purple, instead of 6 out of 10, is now 6 out of 20. And the yellow is 10 out of 20. So this is our red, green, purple, and yellow. So the probability of drawing a red marble, like we just did, is 1 out of 20. How does a probability model help you predict how likely an event is to occur? Probability model shows all possible outcomes. So then when you look at all the possible outcomes, you can decide how many are favorable out of how many total outcomes there are, which shows you the probability, and then you can decipher if it's likely, unlikely, equally likely, impossible, or certain. Example number 2. Use a probability model to evaluate a situation. Ms. Stillman has a marble jar for the same purpose, but students do not know the number of marbles or their colors. Each of 30 students draws a marble, notes its color, and then puts it back in the jar. Based on the results shown in the table, what can the students conclude about the probability of drawing a red marble? So develop a probability model based on the experimental probability. So our sample space, there's red marbles, blue marbles, and green marbles, because nobody drew a marble any other color. There were 30 people, and 4 out of 30 chose red. So here's where our 4 comes from, and we knew 30 students, so we got 4 out of 30. 11 out of 30 chose blue, and 15 out of 30 chose green. Based on this experimental probability, Ms. Stillman's students can conclude that the probability of drawing a red marble is about 13 1/3%, because they can do 4 divided by 30, which is going to give us 0.13 repeating. Move that decimal twice, and you get 13.33333, which is the same thing as 13 1/3. Example 3. Use a probability model to make an estimate. Ms. Stillman tells her students that the jar contains 100 marbles. Based off the table of marble colors after 60 draws, about how many marbles of each color are in the draw. So first, our probability model is the sample space of red, blue, orange, and green. Then we make our probabilities. 7 out of 60 were red, 20 out of 60 were blue, 1 out of 60 was orange, and 32 out of 60 is green. Then we want to know if there's 100 marbles, how can we find out how many of each color are in the jar? So you're going to set up a proportion for each of these. So 7 out of 60 is equal to x over 100. When you cross multiply and divide, you get about 12 red marbles. Same thing with the blue marbles is 20 out of 60. And you want to cross multiply with that to find out how many are in 100. Cross multiply, you get about 33 blue. Do that same for orange and the same for green. So to reduce the number of homework passes, which color of marble should Ms. Stillman use on the pass on homework? So which one had the lowest percentage or the lowest probability? And that was orange. So it had the lowest probability of being picked, the smallest amount. There are only 2 orange in the whole thing based off of our experimental data. Key concept. A probability model can help you evaluate a chance process and its outcomes. You can develop a model using theoretical or experimental probability. A probability model consists of the sample space of an action, events within the sample space, and probabilities associated with each event. For rolling a number cube labeled from 1 through 6, our sample space is 1, 2, 3, 4, 5, and 6, because those are all of our possible outcomes. And the probability of rolling each one is 1/6. Okay, 7th grade, let's say it. I can use probability models to find the probabilities of events. Have a great day.